Hey everyone, this is Divyanshu here. Today we are going to prove that for a linear harmonic oscillator in a ground state, the probability of finding a particle outside the classical limit is about to 16%. Since oscillations are found throughout the nature in such things as electromagnetic waves, vibrating molecules, and gentle back and forth, so we offer tree branch. For a classical oscillator, we know exactly the position, velocity, and momentum as a function of time. The frequency of the oscillator is determined by reduced mass mu and the effective force constant K of the oscillating system and does not changes unless one of these quantities is changed. There are no restrictions on the energy of the oscillators, and changes in the energy of the oscillator produce changes in the amplitude of the vibration experienced by the oscillator. One problem with this classical formulation is that it is not general. We cannot use it, for example, to describe vibration of diatomic molecules, where quantum effects are important. The quantum oscillators differs from classical oscillator in some ways, like the ground state energy of a quantum oscillator is not zero. In classical view, the lowest energy is zero. A particle in quantum harmonic oscillator potential can be found with non-zero probability outside interval negative of A to positive of A. The probability density distribution for a quantum oscillator in the ground low energy state is largest at the middle of a well. To prove it, as we already know, the ground state wave function of a harmonic oscillator is given by psi naught is equal to the alpha upon pi to power 1 by 4 e to power negative of alpha x square upon 2, where alpha is equal to the m omega upon h cut. And according to quantum theory, the energy of the oscillator in the ground state can be equal to 1 by 2 h cut omega. And according to classical theory, the total energy of the particle undergoing harmonic oscillations can be equal to 1 by 2 m omega square a square, where a is the classical amplitude. Now we can say that 1 by 2 m omega square a square is equal to the 1 by 2 h cut omega. By some simple steps we can get a is equal to the plus minus 1 upon under root alpha. In the normal state of the oscillator, the probability of finding a particle in the classical region between negative of a to positive of a is given by p is equal to the negative of a to positive of a in integration psi star psi dx. We can put the value of a in the equation and get integration negative of 1 by under root alpha to positive of 1 by under root alpha and alpha upon pi to power 1 by 2 e to power negative of alpha x square dx. And we can substitute under root alpha x as the q. Now p is equal to the negative of 1 to positive of 1 in integration 1 upon alpha upon pi to power 1 by 2 e to power negative of q square dq. And we can solve these steps up to 2 upon under root pi in bracket 1 minus 1 upon 3 plus 1 upon 10 minus 1 upon 42 plus 1 upon 216 and up to so on, which is approximately equal to 0.84 or approximately 84%. As you already know that the probability of finding a particle from negative of infinity to positive of infinity is unity, and in our proving we have found that the probability of a particle in normal states of an oscillator within the classical limit is about to 84 percentile. Now we can say that the probability of finding the particle outside the classical limit in the normal state of a harmonic oscillator is about to 16 percentile. This is the most beautiful phenomena by which you can say that the particle can lie outside the classical limits. It was all about this concept. We will meet in our next video with a new concept. Till that time, keep watching, keep learning, stay safe. Thank you.